Hello, ladies and gentlemen. Root Beer here. I hope you're all doing well. I'm going to be starting to take a look at another math contest in this video, the 2018 MMC, or Manitoba Math Competition, or I think they say Manitoba Mathematical Competition. It's intended for grade 12 level students. It's written on the same day as the Pascal, Cayley, and Fermat. I know it's written in Manitoba. I think they're branching out to Northern Ontario, and I think Saskatchewan was the plan last I heard as well. People in the comments who are writing it in Saskatchewan or not might be able to update us a little bit better. But it's written on the same day as the PCF to give students in grade 12 something to do, and it's a nice little warm-up practice for the Euclid, which is oftentimes a more important paper during the year for a lot of people. Although you can get scholarship money to some Manitoban universities, I believe, for doing really well on this particular competition. But it's got 10 questions, just like the Euclid. And I'd say the questions are a little easier, but they're still very interesting, which is why I like going through these MMC papers. So here's our contest. If you'd like a copy of this, you can go to their website. The very first link in the description always gets you a copy of the contest. That's how I operate. But we're looking at the 2018 paper. We've got some wonderful sponsors here. But I think they changed the format. I think this was done by, they're starting to do things with Crowdmark. I'm not entirely sure. But it's nice, neat, and interesting. But they definitely did change the format from previous years. It takes a lot of scrolling in between questions for me. But that's because they had a lot of space in these booklets here. Important things to know if you're going to try and practice these contests, which I always encourage you guys to practice. If you're actually going to try it out, remember things like there are absolutely no aids allowed. So specifically, no calculators. But you also can't use straight edges or compasses, although I think that's a bit of a shame, because any student nowadays who could actually use a straight edge and compass properly, anywhere that they would need that on the paper, I think they should be allowed to have it. But calculators, yeah, I understand that. And no phones or anything like that. So if you're actually going to try this, actually try it under exam conditions, what you want to do is take your calculator and put it away. Don't even have it out. That way you're not tempted to use it, because you've got to be able to show all your work, and that does mean all calculations. Okay? So here we go. We'll just dive right in with question number 1. Now it's a two-parter here. Find an integer greater than 1 that leaves remainder 1 when divided by each of 2, 3, 4, 5, and 6. Okay, now they didn't have any specific conditions on this, so we just need an integer greater than 1 that leaves a remainder. So there are tons of choices. There really are. Okay, but how can I be sure that we leave a remainder of 1? Well, what sorts of numbers leave a remainder of 1 when we divide by 2? Odd numbers, and all odd numbers look like 2k plus 1. Now, what if I want, where k is an integer, now what if I want a multiple of 3, or not a multiple of 3, but to leave a remainder of 1 when I divide by 3? Well, such numbers are going to look like 3k plus 1, because think about it, when you subtract 1, the remainder, you get a multiple of 3. Okay? How about really leaving a remainder of 1 when you divide by 4, or by 5, or by 6? Okay? So you might make this connection, but how do we combine them all to get a single number? Well, we just need a multiple of 2, 3, 4, 5, 6, all times some integer k, plus 1. And the only restriction is you can't have k is equal to 0, because then your final answer would just be 1. So without a calculator, I don't want to make these numbers too big or too scary. Now, I could do things like say, well, if you've already got a factor of 2 and a factor of 3 covered by this factor of 6, do you really need an extra 2 and a 3? And you can do things like that to ease your calculations, but 2 times 3 times 4 times 5 times 6, if we just make k 1, the smallest value that is allowed, would be perfectly fine. So 2 times 3 is 6, times 4 will be 24, 5 times 6 is 30, and so we'll get 720, or you could just realize this is 6 factorial. But 720 plus 1 is going to be 721. That is not the only answer. Not at all. I think the smallest answer, just in case you're curious, It would be, so we've got the 2, the 3. We need 2 2's to have the 4. We need 1 5 to have a multiple of 5. And 6 gives us 2's and 3's. So we need 2 2's to be left over. So we'll take these middle 2's. We only need 1 3. So 4 times 5, 20, 60 plus 1 should do the trick as well. So 61 is the smallest positive integer you can use here. But 721, I'd say, comes out quite naturally and is not a very difficult calculation to make. So that finishes off A part. Now what about B part? If A squared minus B squared is 42, and 2A plus 2B is 14, find 3A minus 3B. Okay, I have no idea what A and B are. I also don't really need to know what A and B are. Okay, so the first thing that catches my eye is that A squared minus B squared is 42, because the left-hand side here has a very nice, well-known factorization. This is called the difference of squares, and it allows me to factor. And you might say, well, how'd you know that? It's the sort of thing that you learn as you do a lot of contests, and it's something definitely to sort of have in your back pocket. It's a very useful factorization to be able to recognize and use. But what does this get me? Well, I've got A minus B, and they're telling me 2A minus 2B is equal to, I think it was 14. Oh, sorry, 2A plus B. 2A plus 2B. So what does this tell me? Divide by 2, A plus B is going to be 7. We'll divide by 7 on both sides. I'm left with A minus B is 42 over 7, which is 6. And what do I want to get? I want 3A minus 3B. Well, that's just 3 times A minus B, and I know that that's 6. So we get 18. We got to show all our work. We've got it all there. 18 is going to be our answer here. Now, this isn't the only way you could do the question. You could, of course, say, well, I've got 14 times 3A minus 3B is equal to 2A plus 2B, and then you'll get 3A, 3A minus 3B, and when you expand all this out, you'll get 6A squared minus 6B squared. And, oh, that's 6 times 42, and you can start dividing on both sides and get rid of your, well, you don't need the 3's, you do need the 3's, sorry. You don't need to eliminate the 3's. And you'll be left with 3A minus 3B. 42 divided by 14 is going to be 3, so 6 times 3, again, 18. Okay, I wouldn't do that because I'd feel tempted when I saw the 6 times 42 to multiply it out. I don't know that one off the top of my head, and I wouldn't want to ruin any calculations by trying to do extra work. But I'd say the first way we did it, where we get this 18 in a very nice, clean way, is probably the best way to do it. Okay, so that wraps up question number 1. In the next video, we'll be taking a look at question number 2, and then 3, and so on. So once again, I'll remind you, if you want to copy the contest, click in the link down below. And that's it for me. Thank you guys for watching. I'll see you next time.